Let's think about how we can multiply 34 times 6 in our heads. And so I hope one of the first things you're thinking about is, oh, right, we can decompose 34 into 30 plus 4, and that'll still be all times 6. And so this is, right, our distributive property. I want to name that. And now we can do our 30 times 6 plus our 30, never mind. I was distributing the wrong number, right? Our 4 times 6. We're going to take our 6 here and we're going to distribute it to the 30 and to the 4. And so that's how we get our 30 times 6 is 180 and our 4 times 6 is 24. And therefore we can have our total as 204. We didn't need to multiply, we didn't need to stack them and multiply the 6 times 4 first and do, right? That's our standard algorithm here. This one is called our partial products, when we decompose at least one of the factors and then move on, not move on, and then we multiply it by the other factor. We can do this, we're going to see partial products also when we have decomposed both factors. So now, clear that. Now think about, this is called a number string because we're going to use our ideas that we just found from our previous example of 30 times 6 plus, I did it again, 4 times 6, right? This was our 204. So now how can we use these ideas to help us with 34 times 16? Well, maybe we already know, maybe we don't think about decomposing both of them, but we can just decompose the 16. We know 34 times 10, because multiplying by 10 is relatively easy. And so that's why knowing our tens times tables are going to come before other ones. And here we can see our 34 times 6, we can use that same idea. So this is the point of why we want to include these ideas of number strings, so we can hold them in our head. We know we can keep, not literally completely in our head. We can, write these parts down. And now, but I bet you didn't think you could multiply 34 times 16, without stacking them or without a calculator. And you just did. Now we can add these to be 544. And now we can think about, okay, what if it wasn't 34 times 6 or 34 times 16, but 34 times 116? Can you decompose either both or one of them and use what we have known, our previous, what we just figured out? I want to think about 34 times 116 as 34 times 100 plus 34 times 10 plus 34 times 6, right? Again, our distributive property, 34 times 10 plus 34 times 6. And so this is our 3400 plus 34 times 10 was our 340 plus 34 times 6 was our 204. And now we can come up here and add them all up. We get 4, 4, 9, 3,944. You can check it in the calculator, double check that it's right. But notice how understanding and using, right, really making great use of the distributive property by decomposing any one factor really helps to simplify this multiplication, and using this structure then just gives us that fluency and flexibility. It's not about getting the answer, the right answer, or being fast, but just having that flexibility that we're not stuck when we see, right, a double digit number times a triple digit number. We could use some of these things that we already know how to do, and it just helps us with that fluency.